Hello again, Kevin Culp, PM Head of Cloud Management Solutions here at Supermicro. We're continuing our podcast on PDU management. We've staged the Schneider Electric PDU in standalone mode. It's a 450 SM. You can see here from my PDU console list that we've exposed new features within that PDU. Schneider Electric continues to innovate and bring in very strong features in their PDU portfolio. And so today's video podcast or video clip is focusing on lifecycle management of this Schneider Electric PDU. In the previous video, we focused on cascading PDUs and the importance of that. And a little bit on that one is we struggled or were challenged with some of the architectural design we brought into the platform as it relates to cascading PDUs, synchronous versus asynchronous APIs. We found that sending the task to the back end was a better user experience for DevOps administrators instead of waiting at the GUI to update the screen from when we communicated with the PDU controller. So we've sent these to the back end for a task-oriented type of API call, which is asynchronous. And so at this point, we'll get into the lifecycle management in a few moments, but I also wanted to talk about some important phases we're bringing in for the notion of SNMP gateway. And this is going to be important for those particular devices out there that are still constrained or challenged with providing just SNMP MIB information. And so building that gateway to be able to translate it as a proxy into APIs that we implement in our platform is important. So most of the industry is transitioning to Redfish-based APIs and their own customized APIs. We still have a couple of those vendors that are still sort of stuck in the proverbial SNMP, and so we've decided to implement a gateway in our platform to be able to support those use cases, which will be important moving forward for a whole data center operative here. So let's dig into the PDU management and look at additional features we exposed in this particular release. It's the 450 SM. You can see here we have a list of PDU consoles or PDU list of PDU vendors that we work with. We talked about this earlier. Those PDU vendors are important to build in our universal agent to support our liquid cooled data center use cases for enforcement policy shutdown when a leak is basically detected. And so we're focusing today on Schneider Electric's rich features. So let's click on this particular PDU itself, and let's look at the outlet list information that gets exposed within this platform. You'll notice the first thing is we provide an extensive table list of various different attributes or metadata that we pull from the PDU controller itself. You see here an index listed from 1 through 8 and so on and so forth, as far as how many outlets are contained in that PDU or banks. And then we also provide the type of outlet type, whether it's C13 versus C39, the different states of the PDU, and also energy, current, power, and so on and so forth. So you ask, well, gee, why, Kevin, do we basically provide threshold settings for the PDU? And an important thing about that is to be able to send those alerts when you've reached those certain threshold settings so that you can alert on it, right? And perform action. And maybe perhaps you've overloaded a PDU and you want to get an idea of how much current or load is running associated with that PDU or what the peak power is. So these are all important analytics data that you need to pull from a PDU. And you'll see later on as we continue to focus on sustainability and power management, where we're starved for basically electricity that's coming from the grid, and how do we provide interesting use cases around solving those problems at the grid and at the data center. So look forward to some more content that we're going to build into our platform. So stay tuned for that. We'll be building that with some interesting energy management companies that are actually looking at grid management is an important aspect of sustainability. So let's run through a couple of simulations or demonstrations of shutting down the PDU and setting up those thermal threshold settings. So first thing I'm going to do here is check the four outlets in sequence here, 1, 2, 3, and 4. You'll notice they're in the on position. So we want to basically in bulk turn off all these four outlets. We don't see any power associated with these outlets, so we have no servers on them, so to be safe to basically test in our environment here. So we're going to go ahead and issue an immediate off condition here. And at that point, we'll send a task to the back end to initiate the power down of these outlets. You'll see here that we have a task that gets generated here to let you know something is happening when we initiate this task. So it's important to provide visibility. You don't want to be sitting here waiting and saying, okay, I performed this action. Now what's happening, right? Is something happening in the platform? What's happening in the back end? So bringing that into the forefront and giving you that exposure is going to be extremely important. So let's go and look at the actual log here and see if we performed this particular task and if it was successful. We're going to click on the All Tasks option and look at the various information here to indicate that the four outlets that we basically had sequenced on, 1, 2, 3, and 4, we performed that action to basically shut down those PDUs. So let's say, let's go back in a minute here. We'll show whether those PDUs were successfully updated on the GUI. But let's look at a couple of more interesting information here that we can take a look at. And that has to do with the PDU location, the start time, when we started the action, when the task was performed, the end date, the end time when it was performed, and it was also successfully completed, and who was the owner that initiated this particular action. So let's cycle back to the PDU console and then click on that option, and let's see if those PDUs did get shut down based on our enforcement action. And you can see here that the state for outlets 1, 2, 3, and 4 are sitting in the off position. So let's go ahead and turn them back on again by clicking on 1, 2, 3, and 4 again, and then coming over to the power management and initiating immediate on of communicating with the PDU controller. You can click here, and by redirecting over to this task, and you can see here it has actually been pinpricked to indicate that that was the toast message that immediately redirected me to the log page, so I can look at the important log information to see that this action was basically performed. If I want to basically export this information as far as log information, I can do so in a format which is going to be useful for you to be able to collect logs to later be sent to your Supermicro personnel, or maybe you wanted to do some harvesting of logs for your own troubleshooting purposes as well. All right, so we'll connect back into the PDU console again and choose that option, and let's see if those PDUs get turned back on again. And you can see here, they have been turned back on for outlet 1, 2, 3, and 4. So what else can we do here? We can actually do some tag management. So if I want to edit a tag, maybe I have a specific application that is connected to this PDU. I want to be able to document it. Maybe I have that special server that I want to be able to tag here, which is going to be important for you to look at the outlet tag to see what server is connected to what and how you associate that within your rack management configuration. So let's also look at what we refer to as the edit power thresholds. And these values, if we were to essentially uncheck them, they would not be candidates for what we call threshold settings, right? So we would not be able to activate those and send those based on alerts. So if we want to be able to click on each of those options, we uh, essentially activate those threshold settings. And maybe we want to go ahead and change a high warning now to say 400. And then we maybe want to change this value to 1700. And then we will save the option. And at that point, it'll send a task here to be generated. We can click on that again and see that these threshold settings were successful. And then let's go back into the table and see if those changes were reflected in the table. So click on PDU console again, up to the PDU location, which is our Schneider Electric PDU, and we can look at the table settings and see that those values have now been basically changed. And you can see here that we're actually making changes here, or at least alerting and showing you different critical alerts that are based on these threshold settings. So that's important to send those. So those could be initiated through webhook architecture that's built into our platform, through either SMTP based, through some type of relay mail that gets alerted within your data center, or it can be sent in through a collaboration tools such as Teams or something like that to alert you to indicate that some of these threshold values have been met, or high water markings have been met. And for you as a DevOps administrator to take those mitigated responses, or take some action upon those alerts. So that's in a nutshell how we look at alerting, the outlist, tag management, and shutting down those particular outlets. So we can look at other detailed information here, which is again sensor data such as device energy information. We show various different metadata here within our standalone configuration. So we showed this in previous videos where we show metadata that we collected from the PDU itself for getting an idea how you're performing lifecycle management or monitoring these particular PDUs. And then you can also look at device information here showing you different charting. You can see here by making changes into the threshold setting or looking at metadata that we provide within our backend, you can see charting and graphing associated with this. And this is time series. And then you can go alongside here and look at each of the metadata data points that you're collecting. And then we can look at also phase information too as well, such as power phases and the various different voltage that we are seeing here. You can see specifically tracking data associated with that. So these are all important aspects of getting a visibility of how well or how much data, how much power that's being initiated or load on each one of your phases and outlets. So we can look at banks as well. So all this data is extremely important for DevOps administrators to basically collect. And then you can also look at outlet information too as well. You can see different data here. We don't have any load going in any of these PDUs, so obviously there's zero values. But if you had some load in here, they would be charting appropriately. And then the last one is the environment variables that we have. We have environment temperature, humidity, and sensor data as well that are present within our lifecycle management of this Schneider Electric PDU. So that completes this video clip and focusing on specifically product SKU of the 450 SM, which is the Schneider Electric. Next video, we'll focus on showing you again how you would initiate a task or a number of shutdown of PDUs and demonstrate that in a cascading PDU setup. This one was specifically in a standalone environment. Thanks for joining today. You have a great day, and we'll see you next time.